Who's your daddy? Who's your daddy?
No, really. Who is your daddy? Is that your daddy? Sometimes you can establish paternity and paternity cases by analyzing blood type, and that's how we will be studying the inheritance pattern of codominance. Codominance is when one trait may be dominant, one allele might be dominant over another allele, but not dominant over all alleles.
Like in this example, the reason why genotype AB makes a type AB phenotype is because neither A masks B or B also does not mask A. But genotype, allele A does mask the I, allele B does mask the I, so therefore the I's are the recessive alleles in this scenario, and both A and B are co-dominant with each other, yet completely dominant over I.
So if a child is type O, you'll see right there.
Child. Type O.
Type O, its genotype is II.
Has to be. No other choices. I.
And if a mother is type A,
Mama.
So there's two possible genotypes that it could be.
Type A or type A.
It could be AA or AI. We don't know which one. And then the father. If the father is the father, that's what we need to find out. But if he is type A,
man,
he could be AA or AI, just like the mother is. Now we want to find out, is it possible for a man who is type A and a mother who is type A to produce a child who is type O?
Let's check it out. So we have different possibilities. One, mom could be this genotype and dad could be the same genotype and they could cross. We also have mom being this genotype and dad being AI. And we also have a third option where both parents are AI. So we have our three different possibilities of crossings. So let's build them into Punnett squares. And we're looking for a child who is type O, which is II. That's the genotype we're looking for. So if the first crossing we put in here, the only options of alleles that these parents are going to give are A's, and you would see by doing a quick Punnett square, and these should be getting pretty quick for you guys after all these examples, that there's no possibility of these parents having a type O child. So this example does not produce a possibility of the child. Let's do this next Punnett square. We have mom with type AA or dad with type AI, and we can build our Punnett square quickly. So even though we have two separate genotypes, we have homozygous A and we also have heterozygous A, there's no chance of a child with type O, and so that's not an option. So let's try our last crossing. I wish I left a little more room here. Maybe I'll do it up here. I'll do it over here. So dad, AI, mom, AI. When we do our Punnett square, we have a possibility, let me get my highlighter, a possibility of a child with type O blood.
Looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities and 1 out of a 12 chance of that father producing a child.
Cool. So if I was going to write genotypes percentages for this, you would say 25% genotype homozygous A, 25% genotype II, and 50% genotype AI. But this is the time when phenotypes and genotype percentages don't match. 75% of the time, when AI mates with AI, it's going to produce type A blood, and only 25% of the time type O.